Alright, so with Unit 2, we're going to start talking about the derivative, which is one of the most important things we're going to talk about in calculus. It's like basically one big half of calculus. So to help us get an idea of what a derivative is, we're going to draw a picture together. Now please forgive my straight line drawing capabilities on my tablet. They're going to look a little wonky. See, I told you. Okay, so those are my axes. Then let's just draw a graph, make it look something like this. This could be any graph, I'm just picking this one here. And so what we're going to look at is we're going to look at a point x. So here's my x point. So let's go ahead and mark that up on the graph. Let's call this function f of x. So that point right there would have the coordinates x, comma, f of x. That's the x-coordinate and the y-coordinate. And we're going to pick another point that's some distance away, let's say over here. And we're going to call that x value x plus h. And so that means that these 2 points are a distance of h away from each other. So then that point would have the coordinates x plus h is its x value, and f of x plus h for its y value. You just take the x value and plug it into the f of x. And then we're going to draw a line between them. Let me just change the color. If you have colored pens, now would be a great time to use them. Oh, where did my pen go? Oh, there it is. All right. So you should be drawing a straight line. It's a little bit difficult for me. Okay, so if you remember back from geometry, that kind of line has a special name. So a line that goes through 2 different points, and that is called a secant line. Okay, so let's take a look at just below it. So what does the expression f of x plus h minus f of x over x plus h minus x represent? Think about that for a minute. Think if that sounds familiar or seems familiar. So hopefully what you realized is that the numerator is the y value of the second point minus the y value of the first point. And then that's divided by the x value of the second point minus the x value of the first point. So this is actually the slope. So this represents the slope of the secant line. And you might be able to see the expression simplifies a little bit here in the denominator. And so all that's going to happen is those x's will cancel out. So we're going to have f of x plus h minus f of x all divided by h. So that represents the slope of the secant line. And so now what we want to think about is what would happen if these points got closer together. So in other words, if the h approaches 0. So if h approaches 0, what's going to happen? So think about this point moving closer and closer and closer to our original point x, f of x. So if that happens, once we move closer, if these points are really, really close to each other, we're basically just going to have a line at the top of the graph that only goes through one of the points. And so I'm going to try to draw this here. Just pretend it goes through that point. This is going to be the tangent line. Again, from geometry, remember, the tangent line is the line that kind of just brushes right up against the graph at a single point. So it doesn't go through 2 points like the secant line, it goes through just a single point. So then we're going to say as h approaches 0, so in other words, the points are getting closer and closer together, the secant line becomes a tangent line. So we're moving these 2 points closer together, You can kind of think about what the different lines would look like if you connected them. And then once they're really, really close together, it's basically going to be a tangent line. And so this limit, we can say that as a limit because we're saying h is getting closer and closer to 0. It's not equal to 0. They're not the same 2 points, but they're very close together. So limit as h approaches 0 of f of x plus h minus f of x, all divided by h. That's going to represent the slope of the tangent line. So if you look back up here, the equation without a limit, that's the secant line. If you look at the equation with the limit, it's a tangent line. And so this is just our formula, the definition for the slope of a tangent line. We can't use the change in y over change in x formula that we used up here, because at a tangent line we don't have 2 different points. We really just have 1 point. So we have to use a limit to represent that. So let's actually try to find the slope of a tangent line for an equation. So we're going to say that f of x equals negative x squared minus 4x plus 1, and we're going to find the limit as h approaches 0 of f of x plus h minus f of x all over h. And so in order to find this limit, start out by writing your limit. And then f of x plus h just means I'm going to plug in x plus h wherever there was an x in this original equation. So I'm going to write f of x, but instead of any of the x's, I'm just going to put parentheses. So I'm going to do that first. Negative something squared, that's what the x is, minus 4 something plus 1. Okay? But if we're doing f of x plus h, that means that I plug in x plus h for that something. I'm going to change my color. X plus h and x plus h. So that's my f of x plus h. That's the first part. And then we're going to subtract f of x. So minus, and use parentheses here because otherwise you might forget to distribute, minus negative x squared minus 4x plus 1. And then we're going to divide the whole thing by h. So that's just the setup for this problem. You might think about trying to plug in 0 right here, but just trust me, you're going to get 0 over 0, which means more work. So what we actually want to do is try to expand the parts with the x plus h's. Now keep in mind this first part with the x plus h squared, that really means x plus h times x plus h. So you have to FOIL that out. And we're also going to have to make sure we distribute that negative sign. So we have the limit as h approaches 0 of negative x squared. The middle term is minus 2xh. And then the last term is minus h squared. So again, that's just from FOILing this out and distributing the negative. And then we need to distribute the negative 4. So minus 4x minus 4h. Plus 1, and then distribute that negative in this last part, plus x squared plus 4x minus 1, all over h. So at this point in your limit process, hopefully something's canceling out. So let's see what cancels out. The negative x squareds and the positive x squared. The negative 4x and the positive 4x. And the plus 1 and the minus 1. So this is now the limit as h approaches 0 of minus 2xh minus h squared minus 4h, all divided by h. So at this point, after you've expanded and canceled, you should notice that every term up here in the numerator has an h. And so if that doesn't happen, then you might want to check that you did to make sure you didn't do something wrong, because that should always work out. And so what we want to do is factor out an h. Limit as h approaches 0, h times negative 2x minus h minus 4, all over h. And once we factor that out, we can see now we can actually cancel out the h's from top and bottom. So we have now just the limit as h approaches 0 of negative 2x minus h minus 4. And so now all we can do, we can just plug in 0. Remember, once you've canceled something out, that's when you want to go back and try to plug in. Make sure here we're only plugging in 0 for h. We're not plugging it in for x. It's kind of tricky when there are two variables. And so our answer is negative 2x minus 4. So that equation represents the slope of the tangent line at any point x. So if I actually want to find the slope at like x equals 1, I would have to plug in an x value there. So this is called the derivative of the function f of x. When we write that, you write it like f apostrophe of x equals negative 2x minus 4. But when we actually say it, we call it f prime. So f prime is the derivative, and this is its equation. All right.